Hello everyone, welcome to educators.com. This is Surya Prakash, your Unix trainer. This video is about the processes in Unix. In this video, we'll discuss about processes and the mechanism of process creation. We'll learn how to execute a job periodically and also batch-wise. We'll learn how to create a process and how to change the job process priorities. As we know, Unix is a multi-user, multitasking operating system. That it means at any instant, there might be several programs of several users running in the memory. All these programs share the CPU's attention between them. So thus, by ensuring the CPU doesn't remain idle uh, until and thus by improving the overall system efficiency. There is a common misconcept that the everyone has, that is program and process are one and the same thing. They are nearly same, but they have a little difference. When a program starts executing, then it gets the status of a process. Thus, we can say a process as an instance of an executing program. There might be several processes running in the memory of a system. So, but CPU can cater only to one of those processes, as the other process might be waiting for their turn. In CPU, there exists a program called scheduler. It will be running all the time in the memory. This is the one which decides which process to be executed first. So at any instant of time, a process can be in one of the following six states, that is wait state, or in hold state, or in ready state, run state, submit state. So these are the few. So we'll discuss what are these exactly states. So whenever a program is executed, it is sent to the queue by the scheduler. This queue is called as a process queue. So at this point of time, our process will be in a submit state. Now here our process waits for its turn in the queue. At this point, the process will be in the hold state. So whenever our process becomes the next one to be executed, or the next one to get the CPU attention, so at this moment, the process will get a ready state. So finally, when our process gets the attention of CPU, it starts executing. So at this moment, it will be in run state. So some processes might be doing some IO operations. So as IO operations are a little bit slow, so our CPU might keep that particular process in wait state, and for the process to complete and then to come into picture. So at this state, it will be in a wait state, and after that, whenever our job is executed, or whenever our process comes to an end, it acquires a complete state. So when once the process is completed, it will be then removed from the process queue. So this is how our process attains different states in its execution. So there are two types of processes, those exist in the system. So one is foreground process and the other is background process. To get a very to explain it simply, we can say we use uh, our operating system or Windows. For example, if you consider Windows, whenever you open a WordPad editor, or some editor, or whenever you are watching some movie, the player will kept on open, and it's visible, and it will be running on the system, right? So that process is called as a foreground process. So whenever you want to take some background process, so your antivirus might be running continuously in the backend process, so that can be considered as a background process. So in Unix, so what are the background process, and what are the foreground process, and how to take a job to foreground and background, we will check while we are working on the terminal. So whenever we want to see which process are running at any instance of time, by just typing ps on your terminal, we can see the processes running. We will now log on to the terminal and we'll check how to see the processes and its state. So we are now on the Linux terminal. Uh, this is a Ubuntu machine working on Oracle VMware. So now using PS, we can list out the all the processes which have been running by this users. So now that particular user has logged into sudo bash. So these are the particular operations running. So if I want to check all the system processes, then ps space hyphen e would give the list of all the processes that are been running by the system, I mean, and all other users. So here we can see all the system processes which have been indicated. So at the beginning of each line, you can notice that there is a numeric value for each and every job which is unique and which is not repeated. So that is the one which is assigned by the kernel. So Unix assigns a unique number to every process running in the memory. This number is called as a process ID, or simply we can call it as PID. The PID starts with 0, and it can be running to 32,767. That is the maximum number. So whenever the maximum number is reached, it starts again counting from 0. So if we want to learn about all the processes which our current system is running, so by giving top command, this will show this is the utility tells about all the running process on our machine. So by giving this, it will give the live status of everything. So when you see the white highlighted line, if you notice this, it is displaying some values below this. So when you consider PID, these are the PIDs. If you notice 2816, it will be changing based on its priority rate, which is executing. So PID is the one unique for each process. So next, the user is someone who has initiated that particular task or processes. So then we have a PR, which is called as a priority. We'll discuss more on priority in the next slides. So for now, PR is the one, it can be 20, and the lowest is minus 20. So next, coming to the one NI is nice value, and after that there is a highlighted one VIRT, which states the virtual memory that process is using. So you can see it is continuously updating with each and every process. So next, we can see the RES, which is the physical memory used. So this shows the physical memory uses. And next, SHR stands for the shared memory. So here it continuously displays the amount of shared memory. And after that, we have a state. So in which state it is that process is executing. So if S stands for sleeping, so T stands for stopped, and next R stands for running, and D stands for uninterruptible. So there are five types, and Z stands for zombie process. So now moving on, that it will show the percentage of CPU usage. So how much CPU that process has been using. So next comes to the memory usage. Here it shows the physical memory usage. Next time the total CPU time usage will be shown here. Next, which command is using that particular task, so that command will be shown here. So this is how top command gives a live information about your current node or current Unix terminal. So if I want to exit from this screen, so I just give q, small q will quit and come out of that particular command. So clearing the screen now. So whenever you want coming to the foreground and background job. So when foreground job is nothing but if I am executing ls-l, and if I'm copying, I'm just copying. So now my job has been executed in the foreground. So this is, we can say. So if I want to execute the same job in the background, so I'll just give ls space some, I'm just giving some file name so that it will show. So at the end, if I give ampersand, it will take that particular job into the background, and for that particular job we'll get a reference ID. So we can again restart that particular job. So if this, so we'll give the BG, so job has been terminated once again. So we can bring back that particular job. For example, I would like to give again that particular file. So based on this reference ID, I can give take that to the foreground using this process ID. But as of now, it might have been killed. The job has been no such job because it has been exhausted, because it takes only many minute fractions of seconds. So When you are running some shell script or the job which takes a good amount of time, then you can take the job to the background and you can continue with your work. And like again, whenever it's required, we can bring that job to the foreground. So when we give echo or dollar exclamatory mark, it will give the last executed background jobs ID. So 54323 is the one which for the last executed job we got. So this is how we can find the job IDs for the last background process. Now we'll look about the killing process. So whenever you're working with some process and the process might get hang, or it might using high CPU usage, and it is eating up your system efficiency. So at that time you would like to kill that process. So we can kill a process using PID. So kill PID, that is a process ID. PID stands for. So when we give kill space that process ID, it would kill that particular job task. So whenever we'll give kill and dollar exclamatory mark, this will kill the last executed background job. We can also kill using the signal numbers, that is kill space hyphen n stands for kill forcefully. So then we are giving a PID that would kill that particular job. So we'll now look on the terminal. So how can we work with this? We can also delete the current shell by if we give echo dollar dollar, this will give the process ID for our current shell. So we can also kill the ID of this by using kill space hyphen 9 and dollar dollar. When we execute this operation, this will close the shell. So for now I'm not executing this command. You can try on your systems. It is safe to execute this command. So this is how we can work with kill command. So whenever, and one more thing, to bring a job from background to foreground. So I'll just try to execute this command to take. I'll try to take this into background. So if I give this command, so it will now be executed. So process ID has been generated. So if I want to search for this particular thing, so using grep, then cat is the one by which we can see. So if you see cat, so the job ID we can find, that is a process ID or job ID. So when you want to bring it into the foreground, then just FG, and then we can give the command which we have initiated. So by this command our job comes into foreground. So hello user, now job is in foreground. So this is how we got it. Now we can see the file has been stored here. Though all processes are equal, some processes are more equal than others. So they can be made so by increasing their priority. So the processes with higher priority will obviously get a time slot earlier and would be fired earlier. So that is what they come in early to the CPU and they leave CPU early. So the priority of a process is decided by a number associated to it. This number is called as a nice number. Mm, the higher nice number would indicate the slower the process. So by default a process would have a 20 as its value for its processes. Needs a nice value for the processes. By default is 20. So if we consider some other process has a value of nice value of 25, so when we compare the process with default one, the process with nice value 25 would execute slower than the one with nice value 20. So we can improve the nice value of a particular file by just using command nice value space nice space nice value, whichever we would like to give. Then the command you would like to execute, that particular process you have to mention. So this is how we can improve the nice value. You can give the nice values. The nice value of a process can range from 0 to 39 in some systems. In some Unix implementation, this is also stated as -20 to +20. So by default, if you take in this case scenario in Unix system, it will be 0 to 39. By default it will be 20. So we have a scope of improving from 19 more digits, that is, so we can increment in the range of 0 to 19. So you might get a doubt that as we can improve the nice value, we can also decrease. So we cannot do that, because we can only perform for our particular user values. The root or the administrator can perform the nice value changes for all the users. So coming to the bad jobs, we sometimes need to automate the things. So some particular job has to start on a specific day, or some specific time on a particular day. So these things can be executed using it and batch command. So the it is one which states that at what particular time you're going to start that particular job. For example, I can, if you see the command usage on the screen, so it states that it's space time. That time will be something like whenever you want to start the job. If you want to start the job on a particular day, or the next day, or after a year or 2 years, so whenever we wish, we can run that particular job. And next, for batch also, we can run the batch files using shell scripts. It takes in the form of input direction, and we can execute that. We would now log on to the terminal and check how can we work with these batch jobs. So clearing the screen. So if you want to execute it, we need to have a package named it. So for that reason, there is no package. So now I'm installing the it package. If you notice the screen, I have used a command named apt installed space it. By this, automatically my Unix will get fetch the package from Ubuntu site. It will now trigger everything and it will load. So for now I'm just pausing the video, so that once the complete installation is completed, I'll just log in back. It takes some time. So when you see the progress at the end, it's showing something around 83% earlier. So it's now completed. So we'll also check regarding the batch. Before, I'll just clear the screen. So now I'm giving a job which I would like to expect to run at 6:30 p.m. So whenever you execute a command, the commands the commands, or we can execute the cells at some particular location. So it is stating that commands will be executed using a bin named bin sh. So what is a shell, and what are these different types of shells? You can refer to the video of shell. So now I would like to open a file named vi at that particular time, and I would like to write something. Or else we'll just take a file user.list, and I would like to sort that file, and I'm like to store it a file called out. And I would also, at the same time, we can also perform multiple operations. So sort operation on ls space hyphen l, and I would like to store the output in some file called in fill. So we can give a set of jobs. So when I close this, so it will state that two jobs are being running at Saturday September 17th, and at this particular instance of time, my these both the jobs will be executed. So if you want to check which are all the jobs, the complete list, we can see 80 space hyphen L. Using this, we'll get a list of jobs that have been scheduled. So if you check that at September 18th, 15:30, I have a job, one job, and on Saturday at 16:30, I have two jobs which have been scheduled to run at that particular instance of time. So this is how you can execute the things. So just clearing before execution of batch. So if we want to execute the job in the form of bash, so bash and bash takes the input. So by this we can provide the complete set of scripted thing, and we can pass that shell script using that some. For example, I have some input.sh. So this is the shell which I have complete input information. So as of now, there is no input.sh on my desktop. So let's see, it is an expected error. So in similar way, you can define a script which will have a complete information of the job which it should perform. So by that, we can execute the batch job. And we can also execute bash in the process. So whatever the jobs we submit at the bash will also go at it queue. So they can also be removed from it queue. So if you see, all the jobs declared from bash or listed in the 80 space hyphen L. In that we can see all the jobs. So I'll just try to write some command into some file name inl. So this command would be executed. So at some particular job, so at particular time there are 5 jobs. So if I see 80 space hyphen l, it will be showing the jobs which have been decided from the batch also, which we have uh, want to be executed from batch job. So those all will be listed in 80 space hyphen n, that is in 80q. Any multitasking operating system must provide tools to permit scheduling of the process as per the system or user's requirement. Unix is no exception to this. In fact, Unix is the best at understanding of the time, and Unix understanding of time is marvelous. So as we seen earlier, it and bash, now we have a cron job by which we can run jobs periodically. So Unix can schedule process to get executed within next few seconds to next few years together. So whenever a user has submitted a process to Unix, directing it to execute the process at some specified time and on specified date in future. So there onwards, Unix takes care of that particular file. And Unix has a great capability of remembering the processes to be executed when the time comes. So no user, it requires no direction from the user to execute that particular job once it's been declared. So, as far we have seen two types of scheduling commands, that is et and bash. Now we are going to see about cron. Cron is a bit different from et and batch. Cron stands for chronograph here. So this system process is responsible for scheduling the other processes. Neither the super user or any user on the system has a right to execute this file, that is etc and cron. It, if you want to track this process, so while booting of the system, we can see on the console that the particular cron has started. So and cron is activated on the host terminal. So whenever we are rebooting the system, we can observe this message. So whenever you check ps space hyphen e command, so always there exists a cron daemon. So this will be continuously running, and this will invoke for every minute in order to execute a particular certain processes. So unlike batch and it command, which are meant for one-time execution, so whenever we give a job in the cron, so that will be executed at regular intervals of time as per our decision. So which input we give to the command. So we'll now log on to the terminal and verify this. Clearing the screen, and now we'll check. If you observe my screen, there is a mail stating if you see on the top, because that is because earlier we have given a few bad jobs at current time, so those jobs have been executed. So the result of that will be mailed to my system. So in this my system, I have received a mail confirming the job execution now. The cron process will be always continuously running. If you want to see plus ps space hyphen e, which includes all the system processes, in that we can check for cron job. So if you type grep cron, so this will list. So this would be continuously running, and this would be invoked for every minute. So whenever you are looking to execute a job with the help of cron, then cron tab comes into picture. So cron tab, and whichever the shell script you have or whichever the command files you have to be run to execute, so we can provide that particular file. So for example, I have input.txt, in which I have all the information regarding the which job I have to execute and commands related to that. So I can write complete to input.txt, and I'm passing to that particular cron tab. So by this, the job will be executed for some on the regular intervals as specified. So this is how we can define the cron tab job. Next. So if you want to check for the cron tabs available, I mean all the jobs scheduled on your system. So if you give cron tab space hyphen l, that will show the list of things that will be available on your uh, system. So for now, there are no cron tab jobs available, cron jobs available in my system. So there is no display. Thank you for watching our videos. Stay tuned for more information.